Yo, what's up, everybody? Welcome back. Today, we are making a physics simulation to try to answer a very simple math question for ourselves that we don't know the answer to. And I will clarify that although it's probably possible to figure out the answer, that's not the fun part. That's not the fun part. So, for context, we are working on this code visualizer. This is its current state. What we are looking at here is there are a bunch of points in this graph. Each point represents some part of a code base, like a function, a type, a file, a folder, whatever, right? They're kind of grouped into chunks right now, right? So anything that's kind of like backgrounded red is part of the math library. Anything that's backgrounded yellow is part of the text library, right? And what we're trying to show with this graph is eventually some sort of like hierarchy, right? There's definitely like some grouping of things that are in like the top level folders, but within like a file or within a folder, there are going to be like kind of sub groupings, right? So like we can kind of see here on the left side here, if we were just like screenshot this, here we have like, here is a group, here is a group, and here is a group. And those groups are probably like the IO thread in the app and the path object and the path render buffer. That's kind of what these three things are. And so what we want to do is we want to find some way to show not only the top level folder that things are in, but also kind of their like child folders. And I'm sure that there's many ways to kind of do this, but what we want to eventually do is maybe use this like colored background as like a mask for drawing some sort of interesting space-like background on these like star-like objects or something, right? And what we're looking at right now is like a Voronoi diagram, which basically says for each pixel on the screen, which point am I closest to? Which is great, which works great for one layer in terms of like masking out which parts are the background belong to which object. But as soon as we start trying to do hierarchy, we probably want to start trying to say like, okay, we don't want like this pixel to belong here and this pixel to belong here, because that means that we'll lose kind of like the level 1 folder mapping, this like big purple blob. If we were to start coloring everything in here like a different color, then they would like create a border with themselves and we would lose the purple. So what I'm kind of imagining is that we still want like some sort of like within some distance to this cluster, how close, like within some distance to a cluster, which cluster am I closest to? Which will allow us to still kind of make hard boundaries between like this cluster and this cluster, but like not really extend out forever from a cluster like this. And what I'm thinking is I kind of want some sort of like relatively cheap way to compute this, right? There's 5 points in this, but as we kind of go down the hierarchy, we might have like kind of more, and it's kind of just like a fun little math problem to try to solve. Quad true question mark? I'm sure that there's a better answer than whatever I'm going to say. But my thought was, we already have this Voronoi diagram, which basically says that for each pixel, how far am I from any given point? Or how far am I from my closest point is kind of what he answers. And so if we want to just use that existing Voronoi diagram, we just need to find a good threshold value that says, okay, I will draw something if I am within this distance from my cluster. And so then the question becomes, what's like a good distance? D equals question mark, right? That's what we're trying to answer. And so my first thought here, which is maybe not the most intelligent, but I think probably good enough, is that we can probably approximate any of these clusters as a circle. If we get it a little bit wrong, doesn't matter, right? And so if we were to approximate this thing as a circle, we can also probably approximate the size of this circle by just doing like a very quick linear scan of the points and basically finding like the minimum and maximum x value, right? If these things are relatively circular, that will give us like a reasonable approximation of the diameter of this circle, which means that we can kind of draw a circle. We kind of can find an area of a circle in here. We also know that there are 1, 2, 3, 4, 5, 6 points in the circle. And I'm sure that there's some sort of like just one-shot mathematical thing we can do to calculate what the average distance between two neighboring points would be. And we can probably leverage that as a way to figure out what this threshold should be, right? We'll say, okay, we want you to kind of fill in the areas between points, but not go too far out of that range. So like, what's like a good distance threshold for that? Poisson? Yeah, I've definitely seen Poisson distribution for sure. I've heard of those words before. But you know, part of the fun of programming for fun is that we get to work on what we want to work on. And in my mind, I'm like, how the fuck would I figure that out? And so my thoughts are, I want to see some sort of graph that says for size of, or okay, I'm skipping a step. You can imagine that instead of distributing points in here, we're distributing balls, right? And if you were to drop balls in here, say your balls have like a size, right? You could kind of say that the average distance between balls is probably the diameter of the ball, right? Center to center distance, assuming that all of the balls are touching each other. Center to center distance is the distance between them, which is the diameter. Now, all we have to do is figure out what size of ball packs this circle well, right? Then we can find the diameters, bing, bang, boom. And so I want to see a graph that's kind of like size of ball, number that fit, right? And then we'll probably find that this graph is either like linear or it's exponential or like something else. But I kind of like, because I don't know how to like one-shot calculate this, I kind of just want to like play with it and see if we can glean any information based off a graph like this. Once we have this graph, I think it will be it should be relatively easy to at least find a function that fits the right shape, even if we don't understand exactly how we got there. So that's why I want to build this graph. And to build this graph, I think the easiest thing to do is just take a bunch of balls and drop them in a ball and see what happens. So we can kind of like just make a ball, drop balls in it, and say, how many balls can we drop before they fall outside? And then we can use that to generate a graph, and then we'll be chilling. So today's task is to basically build this simulation. I'm sure, again, that we could do any other sorts of things that would be better, but this is the most fun solution that I thought of without thinking for more than 5 minutes. So, plan of action is let's like set up some sort of like render context. Full disclosure, I was playing around with JavaScript and HTML pre-stream in happy hour because I knew that it would take me a while to get warmed up. But let's build like some sort of like canvas that like drops balls into a ball, and then we can use Zig to run the simulation, which means we're gonna have to set up some WASM stuff. So we'll initialize render context, we'll position some balls, we'll set up a physics simulation, and then we can draw a graph. And from there, we'll see where we go. Yeah, let's just run in. So we are at 7 minutes into stream. 07:25, 26. And like I said, full disclosure, we did do a little bit of a warm up, but I think it is still valuable to do it again because I think it is worth it. It is worth showing the full process. Okay. So let's get ZLS and Zig in here. And in the pre-stream, we found that we also needed some language servers. So I think we used TypeScript language server. And I think it was VS Code. Actually, we can just check. We can just check. It was TypeScript, VS Code, and then we also needed Python and WASM tooling. So we'll kind of take all this stuff. Boom. Next shell, let's get into a dev env. Oh, we're already in one, but let's get into the right one. Physics sim. All right. Next shell, baby. We did something wrong? Somehow? Actually, probably this, maybe? Oh, ZLG. It's actually telling me exactly what I did wrong, I just can't read. Zig. Alright. Let's set up world's smallest HTML file. Which, you just go to any page and inspect element, because I don't remember how to fucking write these things. But if we do index HTML and we just kind of say we are going to copy doc type HTML, we're gonna make some HTML, and we're gonna say that we have some head and some body, and in our body write hello, and we open this in Firefox, we should see something. Hello. Okay, now we need some JavaScript, obviously. So let's do that as well. So let's just make sure we remember how to do this. I had to, pre-stream, I was looking up learn X in Y JavaScript. I'm so rusty that I literally couldn't remember how to fucking write I couldn't remember how to write a function. So I was like reading this and being like, function, but it's async function in it. No return value, and here we're gonna console log hello, and we probably want shift width 4, tab sock is for expand tab. Okay. And then we do window on load is equal to init. Okay. So now if we go into our index HTML, we do, what is it? It's like script source equals index.js, boom. And then I think we still need a closing script tag like this. And we refresh, we look at the console, and he says hello. Hello. Chillin'. Okay, so let's figure out how to like draw some stuff, right? So we probably want to draw some balls on a canvas, right? So we use the canvas element, and I think it's closing tag, and we specify his width and height, and we also need to give him an ID so that we can like work with this guy from JavaScript land. So we'll say, we are our canvas, please. So now I think that we refresh and we should see kind of just an empty blob here before the word hello. Great. And what that means in here, we should be able to start like working with that thing. So I think we do document, get element by ID, canvas. This is our canvas, and we can tell the language server what type this is. We go type HTML canvas element, boom. We need to get the render context from this guy. So we say, what is it? It's like get context, 2D. And then we try to fill this thing in. So we do fill rectangle please from 0, 0 to canvas width, canvas height. And we have to fill it with a color. So let's fill it with black. Boom, black canvas. Let's go. We are moving and grooving. Okay, so let's say we want to draw like a ball in the canvas, right? So maybe we make that another function, and it's like draw a ball at X, Y, and position. Right, and with the canvas, maybe with the render context. Maybe we'll do it like this. And how can we set like render CTX? Can we make this like a? How do I specify like what types are in here? JavaScript. Like what is this like? JavaScript doc format type of argument. Params. Param render CTX, and then how I specify is type. Param, and this is HTML render context, canvas render context 2D. Yeah. So now can I go like render context and have it like auto resolve? Oh, yes, I can, baby. Okay, so we're gonna draw an arc. For some position, XY. So this is XY with some radius, I guess, as well. And why the fuck did I write pause here? I'm fucking high as shit. And we want to draw the full circle, so it's from 0 to 2 times math.pi. And then here we have like, I think you have to say like begin path here, and then you want to fill it as well. And then here we probably want to set like the style to like, I don't know, red. We'll draw some red balls. So now we should be able to like draw a ball at like canvas width over 2 and canvas height over 2. Boom. It didn't work. Begin path is not a function, probably because we didn't actually finish this function argument. So what is our context? It's CTX here. There we go. There's a little red ball in the center of our thing. We are big chilling. Okay, so now we can draw some stuff. And because we are, you know, stubborn, instead of writing JavaScript like normal people, we will try to write Zig. Because I don't like writing JavaScript, and I do like writing Zig. That's about the extent of it. So I want to run like the physics simulation from Zigland, which means that we need to set up like a WebAssembly renderer in here. So let's do that. Make dir source. And can we like edit source like wasm zig or something. And, you know, the typical thing that we do here is we start by trying to add two numbers together just to prove that we can interact with WebAssembly in some way, shape, or form. So we'll do this, and we need to build this thing in a way where we can interact with it from JavaScript. So let's make a little Zig build script, which takes in a standard builder. And I think that this is stud is equal to import stud. And what we found in our exploration today in happy hour is that you can specify a target by WASM32 freestanding. You say, hey, Zig, could you build this thing as a WASM32 freestanding module? And to do that, we need to construct some sort of like target query, I think. So I think we say like target query parse options. I think it was the answer here, and it was like there's some option in here that you can just like shove a string in there. Arch OS ABI. These come from like, if I remember correctly, like LLVM names. So if you like just specify dash target in a in like a C, like a Clang compiler option, like this is kind of what you would do to get WASM. And then I think that we can like convert this into a target by being like stud target query parse. And so we parse this thing from these parse options. And so this is now our query. Then to get our target, we have to like resolve the query. I think it's like target, like maybe it's in build, resolve target query. Yeah, so we take in this guy and we say, this is our query, please. And this is our target now. And now we should be able to build an executable with this target. So it's like target equals target, and then we need to have some sort of optimization level. So it's B standard optimize options. Boom. What's the point in working on WASM? I just don't want to write JavaScript. It's about the extent of it. There's really not more to it than that. This thing's coming from source WASM. Okay. And then we need a name. So we'll call this like module WASM or something. And then we install this thing. Okay, so we also found, actually maybe we'll show how we got there. So we type Zig build. We wait a second. We give him a little bit of time to think. He gets mad because there is no entry here, so we just say, okay, well this thing, I know we said it's an executable, but we're fucking liars. It's really more of a library. We still have to build as an executable because like Zig stuff, I don't know, man. And I think it's like in here, there is entry equals disabled. And so that should kind of get us past that build error. And then we can check a little bit. We can like see our little module and we can say, is there anything sane in here? So we can say, look, give me the text version of this thing. And we see it's like basically empty, which is kind of shit, right? So if we want to export everything, I think it's our dynamic here is the flag we had to set to say like, I think that it's something along the lines of like, don't fucking optimize out things that aren't called. I think that that's like a flag that you can say like, we're going to be dynamically linking this thing. So like, don't fucking assume that you know stuff. And now we see a bunch of code, which is good. We have like an add function that we can call. So if we go into our JavaScript now, we just have to like instantiate this thing. So I do need to look this up again. I think that we can just go to the MDN reference and just say using the WebAssembly JavaScript API. This is what I'm looking for. We instantiate streaming on the thing. We say, please, sir, could you find me the thing at zig out bin module wasm, and could you maybe like get that thing and tell me when you're done? Import object, we have no imports right now, so we're kind of chilling there. It's await here. Sorry, not async. Okay, and then we should be able to be like console log wasm here. And I think that this will fail because of like some like bullshit browser restriction, right? If we go in here now, he's gonna say cross origin. Oh no, this has to come from an HTTP server. And we're like, fuck you, but okay, fine. So we start up a second shell, runs a Python. Give him a sec, he's gotta think. And we'll start up an HTTP server. with using Python's. Oh, there's one already running somewhere else, maybe. Yeah. Okay. We'll do this. Hit refresh. He's still mad because we actually have to go to localhost now. And am I in the wrong spot? I am. Oops, there we go. And we're so back, baby. And we have a WebAssembly module. Hell yeah. So now we can start like interacting with that module in some way. So we had a function in this thing, add, and we should just be able to be like added is equal to this, and we can look at the added value. Boom, 3. 3 is 1 plus 2. Let's go! We can call some Zig. We can call some Zig now. Let's go. Now, if we want to do anything interesting in Zig, like run the physics simulation, we need some way to inform like our renderer loop, which is in JavaScript. Like, yo, could you like draw the stuff that we made? And so what we were looking at in Happy Hour was like, how do we interact with WebAssembly memory? And if we look at this like WASM to watt dump of this thing, we do find that this module exports a segment of memory. And in that memory, we can start storing stuff, right? So here's the stack pointer, cool. But we can also put other stuff in there. So if we just go into like here and we say pub const some number as a floating point value is like 3.14159 or something, right? Some number. Who knows what number that is? It's unknowable, but it's a number, right? If we compile this thing again and WASM to watt this thing, oh, do I need to export here, maybe? I think I forgot. We do see now that we have this global here, which has the name some number, global 1, so that's this guy. Global 1 is this number. And what we find is that this number looks very, very suspiciously similar to the stack pointer, right? So what we can kind of like deduce from that is that Zig is he's not exporting the value of the constant, he's exporting the memory address of the constant. And so like the way that the WebAssembly to JavaScript API works is that like there's an exported chunk of memory in our WASM module that Zig owns. Zig kind of is like, I've allocated this thing, I've asked you to give me like however many bytes I need to like fit all of my heap and stack, and I can give you pointers to things in here, 32-bit pointers. So I think we should be able to look at this thing, and if I remember correctly, there is this like data view class that they tell you to use. And you can say, okay, so there's some value that we called some number, right? Now this is an address. So we have to look at this from the memory view, and we can say like get, we called it a float 32, I believe is what we expected this thing to be. And so we say, get me the thing at this address, and could you please treat it as little endian? Because for some reason, their default is big endian. And we should be able to like get the number now. Right? We refresh. That's a fucking pie, if I've ever seen one. Which is huge for us. Huge for us, because now we can kind of just put arbitrary shit in WASM land, and we can interact with it externally. Right? So what we can do is we can be like, let's like dump a bunch of like ball positions in here. And we can say we have maybe like some number of balls, right? And this is probably eventually going to be controlled externally, but for now we'll just kind of stash it as a global. And we'll say that this is, you know, we'll have 50 balls, right? And in here, our ball positions will have num balls, right? And if we're going to store these things in a way that we can like access them easily from JavaScript, what I think actually makes sense to do is to store this as like 100 floating point values that represent the X and Y positions, and then we'll just kind of index them, knowing that they're kind of serialized that way, right? You can kind of imagine these APIs as like a serialized, like a very cheap serialized deserialize, right? We're not going to pass structs over the wire because we need to know the struct layout. So instead, we'll kind of package these things in a way that we know how they're going to look and like deserialize them on the other side. So we'll say we'll just kind of slap this in here. A 0 in here this many times, and we should be able to then access this thing as a, I think we can do like balls is going to be ball positions is going to be like memory. Can we like say what this thing is? This thing is a like WASM memory, I think. Maybe it's like WASM WebAssembly dot memory or something. I thought there was a way to do this, but I can't remember. So we'll just have to go off memory. But I think it's slice here. So we can say, start me at ball positions or something. Ball positions. And treat this thing like a float32 array. I think it's like this. And so now we should be able to like log the ball positions and see a bunch of zeros. I think if I did everything right. Yeah, so here we see an array of zeros, 0, 0, 0, 0, 0. And just to be sure that we're doing this right, if we throw the number 1 in here a bunch of times instead of the number 0, we should still see that here. 1, 1, 1, 1, 1, 1, 1. So we have like some interaction. We have like exported memory from Zig that we can work with now. And all we have to do is like run the simulation, right? So what are we gonna do here? I haven't really. This is the extent of where we got to in Happy Hour. In Happy Hour, we just looked at these like ball positions and we rendered them. But now we have to figure out like what are we actually gonna do here. So our simulation, like we said, is we want to take a bunch of balls and put them in a bigger ball. Right? That's the extent of what we're trying to do here. So I guess our initialize function will probably take in like the like container radius. Okay. And I guess also we are probably going to change the ball size by some slider. That's kind of what I'm imagining. So maybe we initialize this with like initial ball size. But maybe later we will like have some sort of way to update this thing. We could even have this like just be a global variable. Like, we could pretend that global variables are the same in this scenario as like class member variables. It's like very similar, right? Just because like they're in the global space. In our case, like the whole WASM module is kind of acting like one class. So we can kind of treat global variables like members, and it's kind of okay. So maybe we'll say this, radius. And this is going to be an F32 defaulting to 1, and then here we'll set this thing. Like this. Balls are ballin'. Huge. Very true. So I guess we have to do like the C++ trick where you throw underscores on this thing to avoid name collision. Like this. Okay. I guess what we could do actually instead is we could put all of this in like globals, but I don't know what that will mean for exports. I don't know what that does to exports. I'm kind of curious now. So let's do this. We also need this to be variable, which means that this is kind of going to live here as well. But numBalls is constant, so he can stay here. I'm kind of curious now, if we build this, and we look at WASM to watt of this thing, what do, so these guys just get like global names. I wonder what happens if we make 2 of these with conflicting names here. What does that do? It just like nukes the second one, I guess. We only see 1 container radius here, even though there are 2 in here. Okay. That's kind of like a nice little interesting quirk of the language. Hello, I think the JS doc would be type WebAssembly.memory. Okay, thank you. Helpful for sure. So we could do like, you're saying we take this, we slap this here, and we do type WebAssembly memory here, and then this is kind of like, then we do WASM memory buffer, and then he should know what type this thing is. Nice, 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 nice. Hell yeah. Okay, so now what? I don't know. We're probably gonna have some sort of like step function. But I don't know what it's gonna do yet. Probably we're gonna take in some sort of like delta here, some sort of like time step. And my thought here is that we probably start by just dropping one ball from the top. So we initialize, maybe we initialize this thing eventually. We draw this thing as like circle, and then we just kind of like put balls up above it or something, right? And we let them fall through the top of the container. And then we do like physics simulation within this thing, right? So the first guy's gonna land here, the second guy's gonna land here, and he's gonna like push him to the side, and they're gonna like end up kind of like this. Sure, let's do that. Let's do that. Which means that let's start with one ball. One ball. And his position, I guess, is going to start like relative to the container radius. So I guess we're gonna go like 4, 0 to num balls. We just position him one radius higher. That's kind of like what I'm imagining. So we're going to assume, I guess, that the container, we need to define some coordinate space, right? We need to define some coordinate space. Pixels makes a lot of sense for us, probably, but it does mean that I think it's more convenient for us and for like the renderer if we define this as 0 and this as y, as height. I'm okay with working in pixels everywhere else, but I do think that inverting the y-axis will help here because it means that we can kind of position our container like this, right? And we can then say that like we position balls kind of here. And then I think that what I'm going to do is I'm actually going to assume that on the x direction, I'm going to say that this is 0. I think I'm going to say that this is 0. And then the renderer will position us appropriately. I think that makes a lot of sense. That will make a lot of things convenient for us in Zigland, in simulation land. So I guess for now, we'll say like height is going to start as the container radius times 2 plus ball radius, right? That will position like the ball like literally touching the container like this. Then we can say like as we increase in height, so maybe we'll actually start with 2 balls. As we iterate these things, we'll say ball positions at ball ID times 2. This is the x position. This is going to be 0. And the +1, these guys need to be accessed globals dot. This is going to be the height. And then we say height plus equals ball radius times 2, right? We go up a little bit. Cool. I guess we can just kind of start there and figure it out from there. Let's just get something drawn. So let's call WASM instance exports init. And then can we like call like, I guess like render frame? And here, I kind of feel like we do the same thing as we were doing in Zigland, where we're just like, fuck classes, we'll just use globals. So we can do like ball positions here. Can you do type annotations? I guess here we do like type is float 32 array. Can you do like or null? Is that like a thing you can do? JS doc union type. Is that like a thing we're allowed to do? Dude, people go, coming into chat just being like, these balls. It's like, dude, that's you're really contributing. That's sick. Good job. So now if we do like ball positions, yeah, it looks like he understands. He understands. That's good. So on initialization, we just set these things, right? So we say ball positions. Do I have to say global here? Do I have to flag this thing as something that's like externally visible? I don't really know how this shit works. But we'll figure it out. Wasm these balls. Jesus Christ, you guys. And then we can call render frame, and I guess that also means that we need like our render context, which is canvas rendering context 2D. We'll just kind of slap this shit up here as well, and then I guess we'll, you know, say or null as well, which means that this guy doesn't need to take in render context anymore. He just kind of uses it global. And then here we just say, instead of doing this, we say render context here. Okay. Okay, cool. So that means that we should be able to like render a frame here. And to render a frame, we are going to start probably by clearing the background. Seems reasonable to me. Does our render context have like, he doesn't really know, huh? He doesn't know like how big he is? Yeah, he does. Okay. So it's fine. It's fine. We will just, you know, cheat some more. Width equals canvas. Width and height is height. What simple math question requires a physics simulator? We are trying to answer how many balls fit in a bigger ball. And I have absolutely no idea how to calculate this. I imagine there's a simple answer. And so I want to graph, as we change the size of the balls that we're putting inside, how does the number of them that fit change? And to do that, I feel like we just have to actually check. And to check, we need to write a physics simulator. It's the only way. It's the only way. Of course. It depends how big the small and the big ball is. Yes, thank you. That's what we're trying to figure out. You can use render context.canvas.width. Oh, really? Oh, nice. He knows where he knows who he belongs to. Thank you. That's nice. I like that. Render context canvas. Good eye. Huge for me. Okay. So we start by clearing it, and then we draw some balls. So I guess we say, let's make sure that these ball positions are clamped correctly. Let's clamp the balls, as you guys would say. Which means that we need to extract like the num balls from this. And I assume that this guy then needs to be sliced to num balls times 4 times 2. So this is each ball has 2 floating point numbers, which means that we need 4 bytes per float plus 2 floats per ball. And that means that this ball positions now kind of like contains that information. Can I like, let's just do this, because I'm not really that confident. Let's just start there, see what happens. Refresh. So here we end up with this byte length of 0, so that's not good. That means we fucked something up. Can we look at this guy? Pubconst numballs should be exported, should be 2. Wasm to what? Numballs, that is global 5, which has a value here. Okay, so can we console log numballs here? Looks wrong as fuck because this is a float 32. Yeah, we're fucking idiots. Much better. This is 2 now, and now this float array. We should be closer now. So we want to slice this thing. Oh, this is end. Right, so we want to go from ball positions to ball positions plus this. Okay. So now we refresh, and this thing now has 4 values in him, which is very good for us. I'm a little concerned that the values look like 0, 0, 0, 0, even though we did, even after initialization, because after initialization, these things should no longer be 0, 0, 0, which makes me think that our memory here is probably wrong. Let's just double check here. Let's double check. So we do have, I mean, that seems pretty clear to me. There's a chance we got something wrong, but yeah, 0, 0, 0, 0 is very sus. If I put 1 here, do they say 1, 1, 1? No, they don't. What if we don't call init first? 0, 0, 0, which makes me think that this is wrong. What if we don't try to get the upper bound here? Still zeros. Concerning. Concerning indeed. Which means that we must be doing something stupid here. But I don't know what. I do not know what. Refresh here? Still zeros? Didn't we have this working? Was it only when we had it out of globals? Oh, maybe I didn't compile. Oh yeah, I just didn't compile. It's a hard life. It's a hard life for us. Okay, so let's put it back in globals. Zig build, make sure. 1, 1, 1. Okay. And then let's make sure to call init and render frame. Okay. Zig build, run. We're still seeing 1s. Okay. And let's go back to trying to clamp this thing. So this should be, what do we say? It was like this time plus num balls times 2 times 4, I think is what we said. Okay, so now we see 4 elements, 1, 1, 1, 1. Now, why the fuck is this not happening? Right? Here we should definitely be seeing like 0, 0, 0, 0. So like what's happening there? Can we, what if we mem set this thing to 0? Does that do something interesting? No. Surprisingly not. Doesn't init take params? Oh, that's a pretty good point. Yeah. Does that really change anything? Can we, like... Yeah, why is this... Can we look at the ball radius and see if it's getting applied? So let's take, like, a ball radius here. And look at the ball radius coming out of this thing, and then log the ball radius, kind of before and after. Maybe. Maybe this needs to be let. And then can we write down ball radius here? Okay. That's not good. It is supposed to be a float though. So okay, so that's good. That means that this is definitely like applying, right? We're seeing that the ball radius is in fact changing. So why, then the question becomes, why are the ball positions not changing? I guess it's possible that this thing has made a copy of the memory, which would suck. That would really blow. Yeah, that would really suck. So maybe this guy has to be a little bit more clever. How do, like, float 32 array. How, like, what are our constructors look like? This is not what I want. No, this is what I want. Okay, so we can take the buffer and the byte offset and the length. So let's try that. So instead of doing memory.slice here, let's do memory offset length here and see if that kind of changes the behavior at all. Much better. Much better. Okay, so it looks like we were accidentally copying the memory out like dumbasses. So fuck that slice function. Okay, cool. So now we have some ball positions that are sane. And let's try to use those in some way. So, are all the balls the same size or can they be different sizes? For the case that we are trying to solve, I believe all balls of the same size is sufficient. I believe that is sufficient. But we probably should. I think that this ball radius will change over time, so we probably need a way to update that as well. So I think we want to do some way to like look at the memory, re-extract the memory from this thing. So can we look at like the WASM here and say that this is a type WASM like WebAssembly? I don't know like what this thing actually is. What does this return? A WebAssembly instantiated source. Okay, so now when we say WASM here, we can just write WASM here, and then we should be able to be like, maybe we say like WASM memory return something as well. And then like WASM data view is like return new WASM memory like this. And then here we can go like memory view is equal to WASM data view. And then we can return this. I think that makes sense. Can we do like console log ball radius? Like this and like this. And see if that does what I want. That does seem to be doing what we want, which is good. Okay, so now when we draw ball, we can assume the radius is ball radius, which makes our lives easier. And I guess now let's just draw the balls. So I guess we also want num balls, which will just get a unit 32 from num balls. Okay. So for let I is equal to 0, I don't know if like num balls here will reevaluate every iteration of the loop. I assume it would, which means that we want like num balls to be computed one time at the beginning of the loop. Okay. And I think it's literally just like draw ball at the position. So we need to look at the like ball positions, I times 2 and I times 2 plus 1. So this is the X and the Y, right? Okay, so now when we refresh, we should see some balls, but instead we see WASM is null, which sucks for us. WASM is null, huh? This is coming from, oh, because we called draw ball before we instantiate the WebAssembly. Okay, we are seeing nothing, which is not good. Not good for us, but maybe the radius is too small. Can we make the radius like 50? Much better. Okay, so we're seeing some balls drawn here. That's probably too big, right? We probably want like more like 20. And we need to make sure that we are now positioning them in the center, right? So like we said, our coordinate space is going to be so that the center of the canvas is 0 and x. So that means that this has to be plus render context canvas width over 2, right? Okay, now they're centered here. And then we wanted it so that the Y position is inverted, right? So we wanted to do render context dot canvas height minus this. Okay, and then if we start increasing the size of the container to like 100 pixels, these things should move up. Yes, very good. So we need to render the container now as well. So we'll take the container radius here, and we'll maybe make it 200 or something. Okay. And that means that as part of our frame, we need to render the container. So let's say that we render this thing. I guess we can draw a ball. It's fine. Well, we can just kind of do it manually for now. So let's make this thing, we'll stroke this thing in white. Okay. I think maybe it's stroke style here. Okay, and then here we're going to use the container radius. Here we're going to use the canvas, the width. This is where he belongs, and then the Y is the render context dot canvas height minus the radius. So I think that puts him here. Yeah, that's perfect. That's exactly what I was trying to draw, right? I was trying to draw the container, then the balls kind of stacked on top, which is big for us. I kind of want this thing to be thicker. Can I change like the stroke width? Is it like, no, how do I like canvas stroke width, line width? So if I do like 5 here, does it get like fatter? You get like a little fat boy? Yeah, that's nice. 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 I guess technically this thing will not quite be perfect because if we are trying to keep the things inside the container, we need to increase the radius of this thing by like the stroke width over 2 or something, but whatever, I don't give a shit. So just be aware that the balls are going to be allowed to kind of roll a little bit outside of this thing. Okay, so let's I guess set up the physics simulation. So what does that mean? I guess we need some sort of like loop, right? We need to say on some timer, do some stuff at some delta, right? So I don't really know what that's going to look like yet, but we'll figure it out. So we're going to have some sort of step function, right? And this is going to take some sort of time step. And we are going to say for each ball, and I guess if we're going to start iterating balls a lot, it kind of makes sense to make like a ball iter, just to, like to make our lives a little bit more simple, right? Which is going to have like an output, which can have like a position, which is probably going to be like a vector of 2 F32s. Other way. So we'll kind of give this thing a name. And I guess here we're going to go like function next returns like, I don't know, self. He's going to return a vec2, and we're going to say like index is a u size equals 0. This guy goes like, I don't know. I don't want to do it this way. I lied. Maybe we do like, function get ball at this index. And he's going to return a pointer to a vec2. I think that makes sense. So let's do like, vec2 is equal to a vector 2 F32s, And I think that we should just be able to actually just like be like return pointer cast of like global's ball positions from idx times 2 to idx times 2 plus 2. I think this might do what I want. I don't know if this is like really super allowed. But we'll see. For 0 to num balls, ball index, can we just do like get ball at index? And can we do like ball 0, 1 plus equals like delta times Excel? I guess we kind of need the speeds, huh? I guess we need like their positions and speeds, velocities. Okay. So we say the ball, let's start with no acceleration to make my life easier. And I think that if this thing is not exported, right, if we just kind of say this thing is like our own shit, we don't have to worry about like working with this like serialized type, which means that here we can just use vec2s directly, right? Okay. So then we just say like, let's initialize these things with a velocity of -1 on y. And then we can just kind of see what that looks like if we start stepping the ball. So we can say ball 1 plus equals delta times ball velocities at ball index y. Yeah. Yeah. I guess we can even like do this. I think we need to splat the delta here. Yeah, I think it's something like this. Yeah, sure. So now in like our index, we have to do some sort of loop, which I don't know. How do you like set like a fucking async timer JavaScript? Like Windows set timeout question mark? Set interval? I don't know what I'm doing. Time in milliseconds. So we just like every 30 milliseconds do a shit. So we just say like set interval. Can I like cancel this thing? Does this just happen all the time? I guess we'll find out. Step at like every 30 milliseconds. I guess we want to render the frame once off rip, and then we're going to have some sort of function step. And he's going to render the frame. He's also going to call wasm instance exports step with like, we're going to pretend that we know the answer here, but we're actually going to say 30 out of 1000 and just, you know, pretend that this is the right step. Fix me actual timer. And then can we like console log step here as well, just so that we have some proof that something's happening. Export step is not a function. What if we build it? He gets mad because he's at wasm zig 10. He doesn't like this. But what if we do this? Close. Pointer cast increases pointer alignment. What if we just say fuck you and do align cast here as well? Okay, refresh. Export step is not a function. Why? Pub export function step. Do I need to control shift R? Okay. So now we're seeing something happen. They're moving, but just really fucking slow. So let's set their initial velocity to be like negative like 50. We do need to build again. God damn it. Okay, we have some fucking movement, baby. Now, obviously, they're gonna just go through the floor because we don't have any collision. But that's okay. That's okay. We are at step 0 of this thing. Okay. So now I guess we just need to apply acceleration. So I guess we're going to apply acceleration. And I guess what? We're going to take in some delta. And we're going to go like for each ball velocity, the y value is decreased by delta times 9.8. Expected one argument is found 0, so apply acceleration gets delta here. And then our initial velocity is 0. And then we should see like apply velocity. And then this stuff goes in. Apply velocity. Like this. That seems reasonable to me. He didn't compile because what? Velocity. Does he want an ampersand here? Yeah, he does. Unreachable executed. Hell yeah, dude. Where? That's really unhelpful. Okay. Let's start here. Unreachable executed here. Let's just comment this out. Try apply velocity. Unreachable executed. What is he unreachabling? On both of these. This worked a second ago. Ball plus equals this. The -- watch command should be nice. Oh yeah, that does seem like it would help a lot, huh? What is happening? I feel like this worked when this was here. Am I fucking high? Oh, maybe I have to control Shift R. We could also like add like a log handler to this, which might make our lives easier. Are you resizing the velocities array? I think it should be fine. Velocities is by numballs. Seems fine. Seems fine, but I think that maybe a little bit of additional logging would be nice, which I think is possible if we... I remember doing this before in our like ball machine project. Let's see if we can see it. Why do these have to move? Because we're running a physics simulation. We are trying to simulate dropping balls into a container and seeing how many will fit. So in here we probably had some sort of like log WASM function. Is it not just a packing problem? But I don't know how to pack. Like I don't know how to pack them. I just wanna, you know, do something dumber. It's more fun. That's not the one. So we log WASM. Oh my god, dude. Here, we said, hey, what a wonderful kind of day. Where's our like entry point in this thing? There's got to be some entry point somewhere. Where we like feed in this log WASM. I guess it's probably here. I think there's a way to like override panic log zig. It's got to be in like std options, right? It's got to be. It's got to be. Std options is std options. Oh, crazily, we've managed to avoid importing standard library until now. But in here, they must have some sort of like panic. No? Maybe not. Maybe if we override the log function, it works? I don't remember how to do this. Set panic log zig. Zig panic function. This. Not what I'm looking for. Not what I'm looking for. Oh, wait. Overriding panic function causes a compiler crash? This will tell me what I'm supposed to do. Oh, it's literally just this? Ah. Okay. But in WASM land, if I put an unreachable here, that's a problem. Can I say void like this? Does that work? Expect to type this? How the fuck is this supposed to happen? Is this worth doing right now? I feel like... Let's see what we did in the ball machine. We don't override panic, I don't think. I don't see us doing that anywhere. Zig, WASM, panic, log. Why logging? I'm trying to get like logs on unreachable. Right? When I want to get like the fucking backtrace. You know? Which triggers like a WASM trap, if I remember correctly. Oh, but maybe it's fine for us to override the panic function, actually. And then, like, what does this do? This calls too much recursion, yeah. So when this happens, we go like panic, 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 which means that we probably need to like WASM trap directly. Which I think is possible. Zig, WASM trap. Maybe you have to like ASM trap or something. I seem to remember trap. Yeah, it could be this. It could be this. Yes. I believe this is what I wanted. Okay, and then here we should be able to log what happened now. So what is like the API of this thing? Like, can we log WASM message here? If we say that we have like pub extern function log WASM takes in like a point, like a pointer to some data. So C pointer to some U8 and len usize, I think is how you do this. And then in JavaScript, we define a logging function, which takes in C, which takes in message and len, right? Here, we look at our WASM memory. Okay. And we view this as a new uint 8 array of WASM memory, probably offset. So we say from message len, like this. Then we do like message data, and we do like, I think it's like a UTF-8. There's some sort of like UTF-8 parser. JavaScript. Text decoder is what I'm looking for. Which takes in, I assume, like a uint data array here. I think maybe it's decoder. Decode? Yeah. So this is now our string, and we should be able to console log message s now. Okay, and then this thing needs to be fed into the WebAssembly thing. So I think it's like in here we have like env log wasm or something like this. I don't remember exactly how this is supposed to be done, but we'll get some errors. Can we not do the step thing for now? Okay. So are we getting some logs? Can we go into I guess maybe we didn't finish the zig side. Okay. He's mad. Probably because this guy needs to write const here. Okay. Can we try something like on init now where we just say like hello world? Hello is equal to hello world. Hello as a pointer and hello len. Okay, can we like, does that do something? He's mad because we need to like pointer cast this probably. Maybe write it like this. Yeah, there we go. So we do get our hello world, which is good. Now we need to make sure, we need to get like this panic thing happening correctly. So what is like the Zig panic API? What is this thing supposed to do? Like language reference? Panic? Invokes this. Which takes message, error return trace, and ret adder. Yeah, so are we not getting the message? Maybe in std debug? Can we say like here, panic message is equal to panicked? Panic maybe? This, and so we say like panic message dot, can we go like this? Oh, we're not panicking anymore, probably because we're not stepping anymore. So index.js, can we turn back on the set interval step here? Oh yeah, okay, here we go. Sick. We got there. Okay. So he is mad at the alignment of that thing. He is mad in here that this get ball function is doing an align cast on something that he can't do. So that's kind of surprising. I would have thought that a vec2 would be fine to be cast from one of these. I would have thought. I wonder what happens if we just kind of say that this is numballs vec2s directly, and like we just kind of pretend that those are exported. You know? Like, does that kind of behave somewhat sane? Like, what do we do this? Okay, I think that that might be working, considering we saw something drawn a little sane. So now this get ball goes away, and we can just actually look at like globals, ball, positions, ball index. Like this. Oh, okay, wait, that looks better. That definitely looks better. That definitely looks better. Okay, so we are so back, baby. I don't like how slow things are moving for some reason. Building physics sim to answer a simple question, I feel like we get it wrong. Great. Hell yeah, dude. So why now? Let's get this panic baby out of the way. He can just kind of say whatever he wants now. Now, why is this so slow? I guess because the units aren't matching up, right? So our 9.8 is in meters, but now we're assuming that each pixel is 1 meter large or something, and that's probably causing some problems. So can we go like I don't know, like 100? There we go. That feels a little bit more sane. What's the question? The question is how many balls, or I guess the question is given a circle of a specified size and a number of points that would be inside it, what is the average distance between 2 points? And so we are simulating that. We are trying to find that answer by just dropping balls into of a certain size into the bigger ball. We can then you run the physics simulation, see how many fit, right? And then we can draw a graph of given a inner ball size relative to an outer ball size, how many fit, and then we can maybe we can probably infer something about the shape of that function based off of that. Because I'm too stupid to actually figure out the actual answer by just doing math. Hey, shh, no, bad. No saying the answer. No answers allowed. Intuition could relate it to the radius. I'm not sure if it's related to. I wasn't sure if it was related to radius or area. You know, and this is just how I want to go about it. It's also just fun to do the physics simulation. Okay, so let's say now that we have to like apply collisions. Apply like border collision, let's call it. And I don't know if we need a delta here. Right, so I think I guess you do, because you you apply some sort of acceleration, like an impulse to the ball if it goes through the edge. And if we do that, then we have to probably, like the strength of that impulse is probably related to how long the ball has been inside the edge. Probably. So I guess we need to do some sort of like circle intersection test with the line. So how do we do that? Let's draw some pictures. Let's draw some pictures. So we have ball. We have outer edge. We are looking for a case where ball intersects with this, right? So I guess we want to find this given a ball position. Given a ball position, we probably want to find. I don't know. We want to find this arc going through. I guess it's kind of the same thing. That's the same thing as doing ball-ball intersection from the outside, which is literally just if the radiuses overlap, I think. So we take like the center of ball 1 plus the rate like R1, and we take the center of ball 2 and we go R2 and we point those guys towards each other, right? And we say, is this distance, R1 plus R2, greater than the distance between the balls? Is how we would determine if the edges are rocking into each other. And so if we want to do, if they're inside, we want to check something else that's very similar, right? It's that is given this guy, if the distance from the center here, okay, so the simple test here is the center greater than or equal to the distance to the radius? That means we're outside. We're inside. No, it's if the distance to the closest edge is outside, then we're outside. We're inside if the closest distance to the farthest edge is inside, and we're intersecting if we're between those two. Okay, so fully outside, like I guess we'll say center distance for each ball if we take the distance from the center container center, which is going to be a vec2 of 0 to container x0 y container radius. Do we not stash that somewhere? Global's container radius, maybe? Okay. We say center, we take the position minus this container center, absolute value probably. We want like the length of this thing. Probably length squared is sufficient. We'll do length to hurt my brain less. Dist, center dist here. Which means that we need some sort of like length function. Which I guess we'll just do in vec2 for now. We'll return what? It's like a reduce with add. You take like a times b, that's a squared plus b squared if you reduce this, yeah. And then you square root this whole thing. Okay. Something like this. Something like this. I guess we can be a little bit more confident if we do C0 plus C1, and then we square root this. I'm pretty sure that's the same thing, but this is a little bit simpler. No, wait, this is wrong. We want, what am I talking about? A0 times A0 is A squared, plus B0 times B0. Am I stupid? Yeah, I am. That's why. There's only one vector in here. There we go. Good thing I checked. Okay. There we go. That makes way more sense. That makes way more sense. Okay, so we have like the distance from the center. And if, so we are fully inside if center dist minus ball radius, center dist is less than the container radius minus the ball radius. Yep. We're fully outside if the center distance is greater than the plus. If we are not fully inside and we're not fully outside, we are colliding. Right? That's kind of what we're trying to say. So then we want to apply some impulse. So we say, like, I guess here it's better to keep the ball index. And we can say, like, the ball velocities at ball index needs to have some impulse applied. So it's going to be like, I guess we want like the direction. We probably want like this like push in the direction towards the center, I guess. So center, we'll say that the center like towards center is going to be container center minus pause, right? This is how we get from the ball position towards the center. We get the center distance by doing the length of towards center, and then we get like towards center, we divide this thing by the length to normalize it, right? And then we can apply some velocity, we can apply some impulse here. So let's just say like delta times like collision impulse. And then here we can do like const collision impulse is going to be like, I don't know, 50 times pix per meter. Something like that. Impulse. Collision impulse. Shouldn't the impulse be proportional to the ball velocity? I don't think so. But maybe. I think it kind of evens out over many frames. If it's like still colliding in the next frame, then it just keeps going. I think that's fine. I guess you could apply an impulse that is... Yeah, I guess you could apply an impulse that's like, how much of an impulse do I need to apply right now to get this thing outside of colliding? Yeah, I guess that's kind of it. But what happens if I do this first? Let's just kind of see. Nothing. Because probably we're not calling the function. So he doesn't like that because length needs to be splatted. Oh, center distance, actually. And then delta needs to also be splatted into a vec2. Okay. Still not happening because... Oh, this is also... Somebody need... Whoa. We need to multiply this by the towards center. Yeah. Like this. So we did see it kind of shoot down here. I wonder, like... I just want to see, like, something happen. Okay, that's good. We did see something happen. The impulse was way too strong. But we should be able to... Yeah, okay. So we do see, like, some acceleration here when they hit the edge, which is good. They're getting pushed in. But it means that the push on the inside is always going to make it so that when the push on the outside isn't strong enough. Right? That's just kind of how this is going to work out because it's a constant value. So whoever said it should be related to velocity, I think is correct. So I think we need to say how far inside are we? Which means that we do like, it must be how collided. So we want to do like globals dot container radius minus globals ball radius. So this is like, I need to draw this. So this is container radius minus ball radius. This is like we are touching. So like dist of intersection of minimal intersection. Okay, we do this here. Then we say center dist minus dist of minimal intersection, right? This is like, how far are we? Okay. If intersection amount is greater than ball radius times 2, we don't have to do anything. Or intersection amount is less than 0. Right? These are the cases where we're done. Then we have like to apply our thing, which means that we need to move ourselves. We just set the ball velocity to just there's no like adjustment here. We just do like negative intersection amount times the towards center. So we move towards the center. We say literally next frame. Go this way. I think. Something like this. And then we assign the position as well. Directly. I think. Unless maybe we just set the velocity directly and let the apply velocity fix it. That might be fine. Oopsies, that's the wrong thing. That's kind of funny. He's getting like stuck to the top because we, after applying gravity, immediately apply the velocity, which is a bit of a problem. Okay. So did we get this right? Center minus pause. Yep. Can we do just like what if we make it a little bigger? What if we make it a little bigger? I don't really understand why this is happening. Why do you need gravity at all? For when they're inside the balls, they're supposed to keep moving. But I've done something stupid because the gravity isn't getting applied anymore because we're like fully overriding it. So we could just try going like plus equals here. But then he's not happening here, which means that maybe like our intersection calculation is broken. We could be, okay, dist of minimal intersection. Container radius minus ball radius. That seems to make sense to me. Because the minimal intersection is closer, right? So that makes sense. Then we look where our ball is, and we're like, okay, how far is that? Intersection amount is how far are we minus the distance of minimal intersection? Okay. So if the intersection amount is less than 0, that means that the center distance was smaller than the distance of minimal intersection, which means that we weren't far enough. Okay. Or we're too big here. What if we just don't cap the too big size? Yeah, I don't understand. There's something that I don't understand about the fact that we're like getting stuck here. It's because there's like a very, very small intersection and it's resetting the velocity to push that very small amount back out, right? And so that's essentially being zero movement, I think. Right? That kind of makes sense to me, which means that there needs to be some sort of like plus equals here. I just don't know what it is. I mean, we could also try setting the ball position here as well. Okay, so that's not good. Maybe plus equals. Okay, so wait, yeah, what am I fucking missing here? This needs to be multiplied by delta, huh? Or maybe divided by delta? I think that's what I'm missing. So we have to say like, okay, how fast did you have to move to correct this shit? Yeah. I think that makes sense. Okay, wait, that seems reasonable. So he moves at like a reasonable speed and then he like hits the fucking corner and then he just gets like launched in and then he hits the bottom and he stays there. Okay, so can we now start the balls offset a little bit to the right or something to see if they... Hello? Maybe one, oh, 1 pixel isn't very much. Ball radius times 2 or something. I don't know. Why are these guys not... Why are these starting centered? Oh, because it's here. This mem set literally does nothing. I see. Okay, wait, that's looking pretty reasonable. He's kind of like sliding around on here. So this is kind of behaving the way I want. He's getting launched all the way through, I think, in some cases. We can reduce the speed of the simulation to check. So we can say that when we step, let's just like go at... Oh, it could just also be that they're like inserting into each other. It's also when we go slower, the simulation runs kind of at a lower granularity. Okay. So now I think what I want to do is I only want to do this if we're moving in the opposite direction of the... If we're moving towards the center, we do nothing. I think that makes sense. So if we are moving towards the center, we take our like ball velocity at ball index and we like check if we are... The dot product is like greater than 0. If it's less than 0, then we are already going the right way and we don't have to fix anything. And that should stop like the launch from the top. So now we just need to put like dot. And this is just like return A times B plus A times B. So for those of you who don't have linear algebra memorized, dot product is essentially if you want to do this and this, you take this, and you basically kind of like project one onto the other. So the dot product of these things is kind of this. Hand wavy. I think maybe one of these has to be normalized for that to be true. We might need to do this on towards center. Oh, which this is normalized. That's chill. That's chill. Yeah, I think that should work. So this should make it so that we don't see them like launch it. Oh, fuck. Why is this not happening? If the dot product, did I not build? No. If the dot product, I have this backwards, I guess. Oh yeah, if it's moving towards the center already, we continue. Oh yeah, that feels pretty fucking good. That feels pretty good. Right, we can see now they just kind of like slowly move in, and then they hit the bottom, and they're like, oh shit, let's get back out of here. Okay, so now we need to apply ball-ball collision. Which is going to look pretty similar to what we've done here, actually. Very similar to the border collision. We need to... for each ball, we look at like some other ball. A pause, A index, B pause, B index. We can probably actually start from 0 to number of balls. And then we can probably go from A pause plus 1 to num balls here. Right, because we only have to check intersections after that with balls from the future. We check like this collision thing. So we say like we have like B relative to A is going to be the ball positions. I don't know, man. We'll figure it out. This is globals, ball positions at A index. Okay, we have A pause. B rel A is going to be the B pause subtracted from the A pause. So, B minus A. Then what? I don't know, man. So we say we get the length of this thing. Dist is going to be the length of B rel A. Okay, chill. And then what? We have to check if they're intersecting. So if dist is greater than ball radius times 2, they're not colliding, so we continue. But then now they are colliding, and we basically just have to push, like, we need to apply some impulses. So we move these guys such that, like, B has to move away. So both of them have to move away by 1 radius. No, by half the intersection. So intersection amount is going to be, is this times 2? Yes. So we have like kind of like the same situation where you have like the dist of minimal intersection is literally 1 radius. Right? And so we say like intersection amount is going to be something very similar, right? It's going to be the dist minus dist of minimal intersection. Okay. So I feel like the dist of minimal intersection is times 2 actually. It's two balls, right? Because we're saying ball, center. This is 2r here. Yeah. So that's the minimal intersection distance from the centers. And so the intersection amount is this. And if intersection amount is less than 0, we continue. Is that true? So if the distance minus this thing, if the distance is larger than the distance of minimal intersection, it's the other way. Yeah, if we are not intersecting at all, because we're doing outside-outside collision, it's if the intersection amount is bigger. So it's actually maybe like this way. Dist of minimal intersection minus dist makes this thing say how much they're overlapping. So if distance is smaller than distance of minimal intersection, the intersection amount will be positive. So if distance is 0, our intersection amount is like we're intersecting by, we need to push by 2 radiuses amount. Yeah, okay, cool. So then we just say that the ball positions of A need to be moved and B need to be moved. So they need to be moved in opposite directions, and the ball velocities have to be applied as well, right? So the like movement amount, we're going to assume that it's like equal, right? So we say like A movement is going to be intersection amount over 2, right? Let's just double check this. We have B relative to A, so our intersection is calculated using, if this is A and this is B, we've got this direction, A relative to B, right? Because we did B minus A, is that true? Yes. Which means that A moves in that direction and B moves in the other direction. So B movement is going to be negative A movement. Okay. Ball positions, A is plus equals A movement. B is plus equals B movement. And then the velocities need to be adjusted such that that movement could happen, right? So we just do, looks like A movement times over delta. I think. Seems reasonable. This feels wrong to me. I feel my gut says that this is supposed to be equals, not plus equals. Did we already try that? Yeah, that seems way more reasonable to me. Like math-wise, that works better in my head. So these velocities have to be like this. Okay. Now let's apply ball-ball collisions. Just see what happens. He doesn't like that because A pause. Yeah, I don't know why I'm using A pause in my index here. I'm fucking high. Movement F32. So intersection amount here this needs to be multiplied by this needs to be like multiplied by the direction. So it's kind of like as vec2 here. Okay. Okay, they are intersecting, which is causing problems. Let's go back to putting a plus in here and just see if that changed anything. Okay, that's a problem. We've definitely hit a bug. We've definitely hit a bug there. Let's just do the stupid thing. Swap the directions here to make sure that we didn't do something really brain dead. That does not seem to be the fix. Okay. Which means that we need to think a little harder. So I guess the question is why are these things stuck? Maybe there needs to be a less than equal to there. Okay. So that was good until they collided. Then they like exploded like mad. And I just want to try, you know, just in case I fuck that up again. Okay. Both of these are no bueno. So what's happening is that the velocities must just be going to the fucking moon, right? So that means that this B position relative to A over the intersection amount halved is just like a fucking problem. It could be because like the border collision is like pushing them into each other. Yeah, it's so weird. They're like, maybe if we just cap it, maybe that also will help. Yeah, maybe we just say like there's some sort of like max velocity. So maybe that goes here. And we literally just go like for I don't know. Globals ball velocities at ball index. We say like if length val the magnitude of this thing is this, if the velocity magnitude is over like max velocity, we just say vel divide by, I think it's like we want it to be at max velocity, right? So we say this thing is, we take its current velocity and we multiply it by the max over its current. I think that's right. And then we just have to set a max velocity, which is we'll set to like, I don't know, 10 for now. Okay, Fart Lord saying please raid Doug Doug. That's annoying as fuck. Unless you're saying Doug Doug please raid us, that's less annoying. But still maybe a little annoying, just not to me as much. Okay. Which way are we going? So we said let's cap the velocities and probably 53. Right, so we need to do dereferences here. And let's see what that does. Okay, so that's the velocity cap way too low. 10x it. Also kind of low. 5x it. Even that seems to be a problem, huh? It's like as soon as they collide, he shits himself. Which makes me think that this collision amount is just like way too fucking large. Otherwise, like, it doesn't make sense to me. Because what's happening here now is that like the velocity caps are kind of only applying after we apply the movement. But also maybe we shouldn't be applying the movement directly. If we're applying velocity like right after these collision checks, then like surely that should kind of fix itself. So that's preventing them from like going out into the middle of fucking nowhere. Something about this is wrong. It has to be. It has to be. I just don't know what I'm missing. Yeah, that should be effectively the same. So I guess what's happening is like we're seeing like some like slight jitter towards the bottom here, right? We're kind of seeing like the bottom guy gets pushed into here, then he's pushed back up, then pushed back into here. But like I would think that every frame we should be seeing like this B guy just go like farther and farther up. Which just really makes me think that like we've done something wrong here. B relative to A. Okay, let's draw this again. So we've done B position minus A position. Oh, yeah, wait, the arrow's pointing in the wrong direction. Yeah. I mean, I think that we've tried this fix already, though. Oh, wait, there we go. That seems kind of fine. Now, I don't like, for some reason, these things are, not rolling anymore. Can we turn off velocity cap for now and just see if that changes anything? Yeah, why are they, like, so stuck? It's because we are... That's probably why this, like, plus equals, we were using it on the border collision here. It's, like, right now we're saying, like... It's because... I know what it is. I know what it is. So we have, like, some ball, right? He's got, like, some like, non-perfect velocity, right? He's coming... Like, maybe, like, at some angle... He's coming like this, right? We're kind of saying like, oh, you went through here. We're going to set your velocity directly to like what you need to be done to push out. But in reality, we need to keep some other component of velocity, right? If he's moving to the right and like also like with a very small down component, we need to push up back against this down component, but we need to leave this horizontal component in there. Right? We've kind of missed that, right? So how do we fix that? We need to say that we apply some amount we have to think for a second. So if these things are if this is a perfectly aligned world, right? It means that we only apply the push in Y. So the answer is that we have to apply the push in the normal direction of the surface. So we add to the existing thing normal times amount. And this amount needs to be basically the opposite. Yeah. So we figure out like how much he's pushing in, not like how much the velocity is pushing towards the intersection. Then we apply the inverse of that plus a little bit extra on the opposite direction. So this has to be like so I guess towards center, is this the normal? I think so. I think so, yeah. Okay. So we say we take the ball velocity and we take them by address because that's easier. And we see the amount of this thing that is projected onto the normal, I think, which we have already done. like vel no like vel projected, we'll call it. The amount projected onto the normal. If the projected velocity is greater than 0, then we continue. Otherwise, we basically say the amount that we need to move is intersection amount minus this thing, because the thing's less than 0 at this point. So this will make it a bigger number, times towards center. That seems reasonable to me. So we'll say like impulse is this, and then we like do plus equals impulse over delta, maybe? Maybe not over delta? Let's see what happens if we just do plus equals impulse first. Nah. I feel like the delta has to come into play here. It has to. Guess and check math, baby. That's not good. So before we did this, right? Was that what we had before? We had towards center intersection amount over delta. So now we want to go towards center times intersection amount. Okay. Okay, so let's go back to what we were doing before, which I think was essentially this. Yep, okay, so we're back to what we were doing before. And now the question is why did what I change not work? So we're saying we're taking like the current projected velocity onto the normal. Maybe this is plus. No, because if the projected velocity is greater than 0, we continue. So this has to be minus. It has to be. Then we multiply that thing by the center direction, which is normalized. I don't see why that doesn't work. I mean, it's very clearly just still falling straight through the floor. So I have to be doing something stupid. I have to. Okay, let's do like... I guess we could just log this thing. You don't need the intersection amount in the calculation of the impulse. You're using make it x really bouncy when the ball velocity is large and sticky when it's small. Do I not want to push it out by however much it's in? I feel like I do. I feel like I do, but I could be wrong. I think that we need to get, let's do, can we add some logging facilities? This will help us. This will help us. Log function. Like WASM log or something, I guess we'll call it. And this thing has like this. This API. Okay. What the fuck is this? Type of enum literal? I don't understand. I don't understand. But we'll see. Okay, so we do like we'll make it like a log buff, which is gonna have like 4096 U8s. We're gonna print into that buffer. with like the log level followed by the format like this, I guess. Like this, I guess, into the buffer. I guess this can be on stack. I guess there's no reason for this to be like that. Then we call log wasm with log buff and you know, formatted. Something like this. And then this thing needs like, I guess it's kind of more like we do. I guess we'll just ditch the message level. That makes this easier. This makes this easier. Yep. Let's just do that. Okay. So now can we do like std log info? We have like the impulse is this. And the velocity is this, and the velocity is this? I don't know. Could the issue be that the impulse and the distance mix with velocity? Intersection amount is a distance. But I kind of thought that I want a velocity that is proportional to the distance of intersection. That's what I thought. I mean, I could be wrong, but let's just see. Impulse here, velproj, and ballvel, I guess. Okay, so we need to say ignore failure here. I guess it's going to be, if we don't finish, we're still going to try to use the entire log buffer. Too few arguments. 1, 2, 3, 1, 2, 3. Is it from this? Flying fucking high? What does he like? Impulse? Too few arguments on buffprint. Am I fucking, oh, args, oops. Let's pass this through directly. Okay, so now, I don't see this shit happening, huh? Oh, but it's because we're getting log spam of everything else. It's kind of hiding it. Console log. Let's get a lot of these guys out of here. Okay. Refresh. Impulse. Okay, here we go. So we're seeing that like our velocity is like strictly downwards. Then that means that the amount that is normal to the ball is less than that, which makes sense, right? Because we're kind of on the right side of this thing, so he's got a smaller velocity. Then the impulse is like what the fuck? This impulse is like a little bit on X, like 100 on X, 800 on Y, which is not enough to overcome the current negative 900 velocity. Which means that we're probably missing like the initial. So it means that this thing is not right. So we have, do we log our impulse here? Okay. Can we log intersection amount? Oh, this has to be over delta like this. I've got the over delta in the wrong spot, I think. Okay. I mean, that's definitely different. So What have I done wrong here now? Am I wrong? So we're like, we want to move. We want to move intersection amount in one frame, right? Which means that with yeah, that feels right. So intersection amount, we were like, we want to move this much. Then we're like, but we also have to make sure that we like increase by at least the amount that this thing is intersecting. Or sorry, like we need to like completely cancel out its existing velocity normal to our surface. Then we need to like really just like shove it out there. So why does this not work? We'll just kind of log a few more things. Intersection amount, delta. Okay. Oh, oops. Okay, so that's where this is the state we were in. Velproj times delta instead. I feel like then I feel like then like we need an over delta here because the unit of velocity is in like meters per second or whatever the fuck it is. I'm assuming that we're multiplying by delta when we do the movement. Yeah, we are. So the velocity unit is like meters per second. And that's why I'm dividing by delta here to turn this into meters per second. Then I can subtract another meters per second, multiplied by like the direction. It would be more interpretable this way, though. I think this is the same thing, but it is kind of interesting to look at. Yeah, that is the same. So here we say, yo, we have intersected by 14. Oh. Is our intersection in fucking pixels? Is our ball position fucking unit pixels? It might be. I think it is. So our ball velocity, we need to make sure our ball velocity unit is pixels per second. Which I think it is, actually. I think everything's in pixels. Yeah, because we have pixels per meter. Yeah, okay. So our ball velocity, our velocities are in pixel per second. Our positions are in pixels. So we're like, okay, we're 14 pixels overlapped. And we are moving 800 pixels per second along, like towards the surface, which means that we need to apply an impulse that makes the velocity an impulse with a length of like 900 ish, right? That's what makes sense to me. Can we like log the ball velocity after? Okay. So we had... Okay, so the old ball velocity, negative 911. Now it's negative 8.7. So clearly we did not do the right thing here, right? That seems to be the problem. Oh, oops. This is what I wanted. Wrong unit, wrong unit. Okay. So we start here and we say velocity, negative 900. New ball velocity. He has this like X movement now, which makes sense. And this shit's crazy high. So it makes sense that he should move to the left. That seems like reasonably reasonable. And he should move more vertically than he does to the left. That also makes sense. It could be that he's still intersecting after. So what happens if we like multiply this, just hand wavy, 1.2 times? Yeah, that doesn't help at all. Dude, my poor little brain. I feel like this is like so obvious and I'm just like making a small mistake somewhere. Can we maybe... What if we slow down the simulation? What if we slow it down? Okay, and we just watch real close. Okay, wait. Can we try with one ball? Let's try with one ball first. Did not expect to see you still alive. Me neither. I was kind of hoping that this would go a little quicker, but we're having fun. Wait, with one ball, it's totally reasonable, actually. So it's probably due to collision from the other ball pushing us back into the wall and causing mega problems, right? Because he's like pushing us in, and then we're immediately like, holy shit, we're so far in the wall, we have to apply like mega velocity to get out. We must have been moving so fucking fast. Or something like that. That's my guess right now. So it's probably that we don't have the right formulas for applying these changes on ball collision. Because we have to do the same shit. We have to do the same shit. Because these guys are like hard coding their velocities again. Can we just do a plus equals here instead and see if that kind of makes things more stable? Not that that's correct, but it might be correct enough. No. Well, of course not. Okay. So, again, these movements have to be along the axis of collision. It could also be that maybe if we change the order that these things are applied, that could change behavior as well. Rather than Googling, this definitely solve a problem about circle packing. Let's work backwards from a simulation. We'll need to make a simulation. Yeah, exactly. Fuck Googling, dude. Interesting. Okay, so what if we just like disable ball collision completely, but have two balls? That's kind of behaving in like a sane way. So I'm kind of down with what we've done in terms of ball wall collision. There's no drag, which is kind of funny, but that shouldn't really be a big problem for our... Dude, that's really fun to look at. I don't think that should be a big problem for our thing. Okay, I guess we could just try applying like the same logic here, where we apply the movement along the axis that we care about, which is we take the existing velocity, we preserve anything about it yeah, should be fine. So A velocity is global's ball velocities of A. B velocity is B. Now we need to make it so that they push each other. God damn it. Okay. So we have like ball. They are coming in like this. They hit and they bounce back. Right? But if one is coming in like this and this guy's coming in slower, right? It means that this guy ends up getting a little bit faster and this guy still moves this way but a little bit slower, which means that we must be looking at the difference between their velocities in some way, right? We must be looking at like B velocity minus A velocity, and we'll say B vel rel A, and we need to apply a change in the velocity in some way. Okay, so it's literally just along this axis still. The velocity change is along this axis, and it's literally just the amount that they're intersecting over 2. So I think that still makes sense, and I think it's literally just like... Is it just that we do plus equals here? No, because we need to know how much... We need to offset the existing velocity of them intersecting, right? So we take the B vel rel A, and we must dot product this onto something. Can we say like intersection normal is B rel A over distance? So this is going to be his current velocity. Yeah. And so then we do this. A movement is equal to the negative dot product of this. So this is the speed of B relative to A along the axis of intersection, right? So that's like this guy, these guys are coming towards each other. So this guy's, let's say we have like B coming this way, right? A is stationary. That kind of makes this easier. That means that this has some velocity this way, which is what we're looking at. The bio checks out. Yeah. Which means that we want to make it so that this velocity adjusts itself so that he comes this way with some small amount, right? Yeah. So we have the B rel A projected onto this thing. So this is B rel A projected. We need to say that the B movement, B impulse, is going to, or the A impulse, I guess is what we did first. Needs to, we need to take, we need to move by B rel A over delta, that's what we did over here, minus B rel A projected. And then this is a little tricky because this is inverted. Here we did towards center. So we need to dot product this onto B rel A projected. Or multiply this. No, multiply this by B intersection normal. Yes. So we're going intersection normal, which is intersection normal is in the direction of B from A, which means that we need to go negative this. Then we take the intersection amount over the delta and add that to B rel A projected. Why is this negative? Okay. And because this is B rel A, this is the inverse of A rel B, so I think it's like this. Probably over 2 somewhere. That's a maybe. That's a maybe. There's like a real good chance that this is wrong as well, but let's just kind of see. B rel A over dist somewhere. This needs to be splatted. So the shapes match. And then A velocity and B velocity are pointers, so these guys need to be dereferenced. And then here we go, A velocity here, and B velocity here. Oh god, I hope that's it. Fuck! Intersection normal, intersection amount delta. Are these not all floats? Delta B rel A projected is a float. Intersection amount. This not also a float? Oh. I see. These need to be splatted out as well. Alright. Oh, come the fuck on, man! Uh-oh, uh-oh. Oh, it felt so good for a second. I suspect that we have a negative flip somewhere. Yeah, it's a lot closer though. A lot closer. This is also a candidate for a sign flip. That felt pretty good. Oh, we fucking got there, baby. Look at that. Look at that. Okay, so there's probably the fact that they seem to be accelerating. Actually, I guess they keep coming to like the same heights. I can't really tell. There might be some sort of like perfectly elastic collision bullshit happening. So we should probably dampen these things. Right? Just kind of like hand wavy. I don't know. That seems kind of reasonable. And then we probably want to apply that same dampening on the... it seems like they kind of like stabilize to the bottom. I guess we kind of want like some sort of like general drag as well. probably. Right? Things should kind of like, I don't know, trend towards not moving, I guess. So this is ball index, and I guess we look at like the velocity, and we just say like velocity times equals drag factor. And we'll just call this like air drag or something. I don't know. So this thing needs to be splatted like this. Hey, Mlug, if you're still here, is there like, do I really have to type this like as vec2 everywhere? I hate doing this shit. If you're like, is there a way to not do that? I think I saw that the splats maybe got a little bit more in free in 014. But like in a lot of cases, I have to type that shit, and it pisses me off. Not that that's really your problem, but okay, that's not good. So I guess this idea of applying drag this way is like, that's a known pain point. Will probably be solved at some point. Okay, so there's not like something coming in like now that's fixing it. Okay, no worries. I was just curious. That's good enough. Okay, let's okay, the elastic collision is too elastic. So wherever that ball collision factor was, can we like drop this like 0.5 or something? Just like maybe 0.5 is too low. 0.7. Currently, B rel A proj is causing the relative velocity to be applied to each object separately. I thought that's what I wanted though, because I divide by 2. I divide by 2, so I think that it's fine. I should be dividing the other term too. Are you saying this one? I can get behind that. That's good enough. Okay, let's crank up the number of balls now. That's kind of what I was looking for. Okay, so if we go like 100 now. I'm hoping that we go outside the bounds and we start to see. Oh, fuck, that's still not enough. 200? I just want to see what happens if we overflow. Oh, that's kind of funny. So as we push more and more in, we're not correctly pushing the balls back out. Because as soon as they end up inside, the like walls of the container are like trying really hard to keep everything inside, which means that like things can never like fall out, which is a little bit of a problem. Okay. Well, we can come back to that. At the very least, we have this part working okay. We just have to figure out how to like get them to like this dense packing here is like a problem, right? The fact that they're jittering here is bad. These guys are kind of packed correctly, but all these guys are packed incorrectly. So I think this was a fun enough experiment for now. It's 4:30. I would have loved to get a little farther. But you know, it is what it is. So we're gonna call it there for today. Thanks for watching, guys. If you like what you saw, we stream most days around 12:30 Pacific time to 4 o'clock Pacific time. It is 4:30 Pacific time now, so you should expect to see us online between 4 hours ago and half an hour ago. We are working right now on this build of visualization of our code map thing, so it's starting to look pretty good. I don't know if you guys saw the latest and greatest, but look at that shit. Oh, I don't want to watch ads. I don't want to watch ads. Let me in, baby. Skip. Like, oh yeah, look at that. Those are some fucking backgrounds of points, baby. Look at that. So this is kind of like current state. It's looking okay. We're working our way forwards. If you want to keep following this project, there's a YouTube link in the Twitch description. We have it organized into playlists. We're working on this. There's a GitHub link in the Twitch description. Today's code will not end up there, but something resembling something will at some point. I think that's all we gotta say. If you're watching on YouTube, you're like 2-hour VODs. You said 4 hours. There is this section of the stream called Happy Hour where we kind of do like prep work, side quests, whatever. So today we were kind of doing a little bit of like refamiliarizing ourselves with WASM and web programming. So if you want to see that type of stuff, there's a join button on YouTube or a Patreon or you can sub on Twitch and those VODs will be available, or you can catch it live from 12:30 to 2. I think that's all we got to plug. YouTube, peace out. Twitch, let's want someone to raid.